Okay, so welcome to Department of Electrical and Computer Engineering. I'll try to give you some basic information about our department, and all this information that I present is available also in ec.ncsu.edu, so you can find this information there too. So our department is a top-notch leading department all around the nation and also internationally. So our education, our courses is blended with a lot of research experiences, and I will also presenting you some of our research in addition to our courses. It's really difficult to separate them. So let me start with Electrical Engineering 101. What is electricity? Actually, it was discovered around 17th century. And during those days, the people didn't have outlets like this, plugs like this to get electricity. So they were using kites, or they were using these so-called Leyden jars. This is a metal. They were rubbing wool pieces to it to charge it, and they were using this to run their experiments. So electrons were something mysterious then, and it's still a mystery. Nobody was able to take a picture of an electron with a microscope so far. We model it, we know something about it, and we use it. So electrons are mystery. Therefore, electricity, which is use of electrons, is magic. And electrical engineers, therefore, are magicians. If you take an electrical engineer, put a time machine, and bring him to 16th, 17th century with their cell phones, with their cameras, they would be witchcrafted because these were the practices of witches. And early in 1900s, we started to have a more understanding of atom and electrons. We thought that electrons are like orbiting like this at the beginning. Based on this information, we built light bulbs, simple telephony, simple telegraphy, simple radios, batteries, dams, thanks to all these famous people with their efforts. But towards the end of the 19th century, we actually found out electrons are not like satellites orbiting around the planets. It's more complicated. They are in clouds, thanks to the understanding of quantum mechanics. And this helped us to reduce the size of our electronics from this all the way to this, where you see atoms here. And this helped us to miniaturize our computers, the ENIAC in Philadelphia, to fit into our pocket. So what is next? Quantum theory, string theory. Our scientists are working in their labs to understand the atom more, the electrons more. As I said, nobody was able to take a picture of electrons so far, maybe in the future. And as engineers, we take all this knowledge, learn about it, and we apply it to the real life to enhance the life experience for our humankind. So National Academy of Engineering actually gave us 4 missions, 4 grand challenges. The first thing that we do is improve our health, fight with the diseases. As a human, when you are sick, you don't care about anything. You only care about getting well, especially if you are really sick. And as you have your health, you are looking for some security around your house, around the homeland. Then once you have your security, you start to care about sustainability. Okay, we are running these cars on the streets, but what happens if one day all the oil around the world diminishes? So then you start to think about the solar energy and etc. And once you have all these major things, you improve the joy you get out of your life. We have, our tiny headphones to listen to music, to listen to podcasts. We have our tiny e-readers to carry our library in our pockets. We have computer games. We have computer graphics in the movies, very cool stuff. So we try to, as engineers, try to contribute to this. And the next big thing coming up is Internet of Things. It used to be Internet of People so far, and think about how it changed the life. I actually was in White House 2 months ago there is an effort to publicize this Internet of Things concept to people. It used to be only people on the internet. Now the cars are internet. On internet, there are these self-driving cars getting into the satellite and finding whether there's a traffic in front of you, and it helps you to avoid, even your simple GPS devices does that. The grid is on internet now. It's becoming more smart. If there's a power outage here, you can bypass the energy around it to bring it to other people. The medical devices are getting into internet. There are all these cool gadgets you wear. Even as a healthy person, you can track your well-being, or if you are sick, you can monitor your vital signs and etc. Our cities are becoming smart. Airplanes now on internet, there's an app for that. If someone is traveling, you enter the flight number, it tells you the altitude of the flight. At that point, it shows you the flight, the airplane on a radar screen, and you see whether there's a tornado in front of the airplane, and you start praying for the people that they will arrive safely. So this is the next big thing, and this is happening. White House Office of Science and Technology Policy is actually imposing this to all the departments. Department of Energy for the smart grids, Department of Transportation for self-driving cars or cars aware of the traffic, Department of Defense for a lot of military applications, National Institute of Health for health-related applications. So there is this ongoing effort by the government, and they try to spend some of our budget such that we are going to lead the world in this next big thing. It's coming up for sure. You cannot avoid it. For us relatively older folks, the world will be totally different. And it was even much different for our parents and our grandparents. So this will continue, and we try to contribute to these efforts with these 8 research trusts, bioelectronics engineering, where we try to couple our electronic devices with the electrical system of the body. And we build, for example, medical imaging devices, communications and signal processing, computer architecture and systems, control, robotics and mechatronics, electronic circuits and systems, nanoelectronics and photonics, networking, power electronics and systems. These are the research trusts that we specialize on. We have around 70 faculty, and we are divided like maybe 10 faculty or 5 faculty between each group, and we try to interact with each other. So what we provide here in this campus to our students is first the facilities. This is a picture from our clean room across the road. This is a special place where we build our nanoelectronic devices. Sometimes the dust themselves are bigger than our devices. When the dust lands on our device, it's like a Boeing landing on a car, on a Beetle car. So the air is filtered, everyone is in special uniforms, and there is an undergraduate level course where actually you get into this lab and learn how to build transistors, and there's a more advanced graduate level course, and we have our faculty doing their research there. We also provide these people. Jay Beliga is one of our faculty last year. He got the National Medal of Technology from the president himself. If you take a course, if you join us, you can actually take a course from him and learn about the power transistors. So we have a number of faculty earn a number of awards. I don't want to list all of them here, but this is what basically we provide here. So we are both electrical engineers and computer engineers. Electrical engineers are the folks working more on the hardware systems in general. Computer engineers are the ones that builds the computers. And there's also a computer science, which is the other side of the building. It's a different department. Those are the ones who gets what we build, and they process information on that. So computer science is more like people working on the abstract things with the mathematical models, with the abstract tools. And electrical engineers are ones who builds the infrastructure to let them play their game. Actually, our computer science department is one of the best in the country for gaming. We develop gaming not only for fun, but also train firefighters. to train military personnel, to train different people. So it's again one of the next coming up big things. So as electrical engineers, we try to reduce pollution with electrical cars, with solar energy. We help poor villages to obtain power for water treatment, food, and medical storage through solar cells. We bring nations closer together economically and culturally through computer networks. We save people's lives through medical imaging. We make transportation safer through automobile control systems, through autonomous cars. And these are two major electrical engineering centers that we have. These are called National Science Foundation Engineering Research Center, NSF-ERC in short. What happens is National Science Foundation every 2-3 years they have a competition, and the winning university gets $18 to $20 million for 5 years, and it is renewable for another 5 years, same amount. And they establish a big center, both the facilities, and we hire new people. So we had one on power for last 7-8 years, and last year we had another one on medical devices. The one on the power is working on power electronics, solar cells, electrical vehicles, smart grid, and the ones working on the medical devices is working on wearable systems that is going to scavenge power. So you probably may be wearing some of these cool gadgets, tracking your heartbeats and etc., talking to your smartphone. But these are the ones that will be self-powered through your body heat and the motion of your body. And just a detail here, our department, forget about our department, the university, NC State University, is the only university that has 2 of these centers simultaneously in the nation. So it is given to a university, then given to another university. We were able to get 2 of these together because of the facilities that we provide and the people that we provide. So the computer engineers are the ones who try to find the needle in the haystack of world's best online resource of knowledge. We try to access information anywhere, anytime, build machines to design new drugs to fight infectious diseases, create autonomous robots to perform repairs in hazardous environments. And some of the things in the real life are these industrial robots, smart household appliances, personal computers, workstations. So this is what our computer engineers do. There is a number of labs around today opening their doors for you. If you have not done it, in the lobby we provide these pamphlets where you can find where these demonstrations are taking place. It is in this building, and we have another building, Montate Research Center, across the street. You can go to these labs and see some of the research performed in these labs. We also perform research on radio frequency circuits, communications and signal processing, robotics, biomedical systems, and these are some of the applications. So why I talk about these research opportunities, basically this is to highlight that our students starting in their second semester of their sophomore year, they start to perform research in these labs if they want. And in addition to learning basics in the courses, they get hands-on in these laboratories, and they learn by practicing on this. And most of our professors are interested in working with undergraduate students. I lead the lab that works on these remote-controlled cockroaches, and I worked this year a total of around 20 undergraduate students, in addition to 7-8 PhD students in my laboratory. So this is how our engineers look like. Your picture would be here 4 years from now. Even if you are not performing research in one of the research labs, we want you to you are required to take a senior design course where you form a team, and we have projects supplied either by the professors or by the local industry around. and you pick one of these projects and you form a team to solve that, and at the end of senior year you present during the ECE design day. So this is to make sure that you will have some hands-on experience. This is average starting salary according to the National Association of Colleges and Employers, around 60,000, and it becomes 10,000 more if you have a master's degree, and this is the starting salary. It becomes over 100K per year. Around, I believe, 60-70% of our graduates become classical engineers, and some others establish their own company. We have an entrepreneurship program offered by College of Engineering, where you learn how to build a business model, how to sell your ideas, how to build a prototype. You can even apply for patents through them with your ideas. The director of this institute is Marshall Brain. He was the who started the How Stuff Works website, which is very famous, and he sold it for millions. So he's a local person. He doesn't want to retire, and he actually is leading this program, and he's working with students to basically develop businesses based on their ideas. Some of our students come to our graduate program, have PhDs, or go to other schools, become academicians or professional researchers. Some of them go to law school, become patent lawyers, make a lot of money, or they go to medical school and they become medical doctors. Those become the best medical doctors because they not only know how the body works, but they also know how the medical devices work. If you look at the medical practice today, 75% of it is through these different medical imaging devices to look inside your body without cutting up your body, or they actually use robots during the surgeries. So the medical doctors with engineering degree are the most successful ones. Some of our graduates become politicians. When I go to the local house here, they say, "Oh, I'm an NC State alumni," and we connect immediately. Some of them go to DC. Some of our students are international. They become politicians in their own country. The prime minister after Gaddafi, the prime minister of Libya, was one of our PhD graduates. He's not the prime minister anymore, but it was like 5-6 years ago, I guess. So we have this strong internship and co-op program. We have a job fair every semester. A number of companies, I can say close to 100, I guess. Tens of companies come to this job fair. Most of them are local, but some of them are coming from Bay Area and such. And they generally send their alumni, NC State alumni, to interact with the NC State students. They either hire professional engineers after they graduate, or they hire summer interns, or they hire co-ops. Co-ops are extended internships where you take a year off, go to company, especially in the sophomore year, before you go to your final year, and you have a 1-year job experience. They don't pay you this much, but they pay you much more than you need, and you don't have a long-term commitment with them, and they don't have a long-term commitment with you. If they like you, they actually ask you to take special courses in your senior year, saying that we will offer you a job. One of my students, for example, offered a job from Microsoft, and they said, "Okay, you will probably working on this project, so you may better take courses, develop yourself on this topic." And when they graduate, they go and immediately connect and start contributing in those jobs. So this is some of the opportunities out there. As I said, we offer 2 degrees, electrical engineering and computer engineering. These two are separate. Our students enter as sophomore, and you need to take courses as an engineering student. Then you become electrical engineering student. We have a threshold of around 2.7 to 2.5 GPA out of 4. It doesn't mean that we are not selective. This GPA based on our interaction with the local companies. They say this year you graduated 200 students, we needed 250. We need more students from your school. So this helps us to lower this GPA and have more students in the department. Someone asked me how many students we accept every year. We accept 210 students. And most of them graduate with either a job offer or a graduate offer from a graduate school. So we also offer, some of our students prefer to do double major. They take more courses and they become double major electrical and computer engineer, or they take courses from the other side of the engineering building too, and they become a double major on computer engineering and computer science. This requires a couple of courses. This requires an additional year. So other students also become a double major with mechanical engineering. They become a double major with biomedical engineering. So these are the most common ones. So all freshman year students take courses with their other engineering buddies, mostly in the main campus. And then next year, in their sophomore and junior year, they come to us and they start taking courses about the electrical engineering. And in their last year, they specialize on topic. So now the field is so broad that you cannot learn everything together. The students who want to work on the power systems, high voltage electronics, are going to take different courses with the students who are going to work on nano devices and really low voltages. And those take different classes with the students who will be basically working with the electromagnetic waves. So our students specialize on their junior and sophomore year, and there are a couple of humanities and physical education courses we want you to take, because we want you to be leaders when you graduate. So the total number of credits are 122. Either you become an electrical engineer or a computer engineer. If you take just 6 credits, a course is around 3 credits, so it's like 2 courses more, 3 courses more, you have a double major. So freshman year, as I said, is basic courses. You don't see anything related to electrical engineering here. Introduction to engineering, introduction to computing. These are common courses for all the engineers. And in your sophomore and junior years mostly, you take courses on electronic circuits, linear systems, electromagnetic fields and waves, logic design. So these are the stuff that we want all the electrical engineers to know. And in your junior and senior year, you focus on power, embedded systems, wireless systems, photonics, integrated circuits, nanotechnology. So you take specific courses from these elective courses. And you also need to take 2 courses on senior design, where you need to work with a team of students on a project. So we want you to be social engineers, not the one that go to a workbench and work very great, but we want you to be able to communicate your engineering. We want you to be able to give public speaking. We don't want any grammar errors on your reports. We want you to have a knowledge of the world in case you become the next president or next prime minister of Libya. So we have an accelerated master's undergraduate degree, bachelor's master's program, ABM. If you are a master's student coming from another university, you need to take courses for 2 years. If you are one of our students in this program, we ask you in your junior and senior years to take a couple of those master's classes, and you need to have a GPA to be able to do this, of course. So we first select our students to this program, and then after we select them, they take some master's courses. Some of our master's courses actually they are not very detailed, so you can as an undergraduate courses take those. And in only a year, you end up getting a master's degree too, in addition to your undergraduate degree with this accelerated program. We offer also master's and PhD degrees here. As I said at the beginning, we are one of the major top-notch university internationally. So we have 70 faculty performing research, and they offer graduate level courses. Each faculty more or less offer one undergraduate level course one semester, a graduate level course in the other semester. We have 500 graduate courses, so this makes us to offer a number of specialty courses. And this faculty also attracts external funding. We bring around $10 million every year from outside sources like Department of Defense, Department of Energy, National Science Foundation, National Institute of Health. We apply for grants, we get this money to here, and we build new equipments with those such that you can perform research, and we pay also stipends to the PhD students such that they can have some life after the after their undergraduate degree. So this is my last slide. This is how our website looks like. You can go there and find the latest news. There's a link for those two National Science Foundation Engineering Research Centers, the one about the medical devices, the one about the power. We start to offer a minor degree for our undergraduate students on nanoscience and technology. You can find more about it here. There's a master's degree on power, science, and technology. The power is the next big thing. President was in our campus 2 months ago announcing a new power initiative taken here. It's a $150 million initiative in our campus. Power is one of the big things at NC State. If you want to become a faculty here, there's also faculty position announcements there. There are some public events that we offer. You can find information about those in our events.